Facebook, Instagram, Twitter, and YouTube.
There you go. Perfect.
For the open of the show.
Okay.
And then when Brian comes over to work a problem, you can either work it from here
Hi.
or you step over.
Yes.
Yeah, so if you're basically going to be there or there.
They're in there.
I'd practice with that a little bit. You can put your hand right on it while you're writing instead of like this board Yeah, I got you. You got me? All right.
I've been using like
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us we have Brian. And Brian, if somebody wanted to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, toll free 866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right. Well, you know what? That was excellently done. Where do you go to school and what grade are you in?
I go to Ronald Reagan Elementary School, and I'm in 5th grade.
How's 5th grade going?
Pretty well.
It's all right so far?
Huh?
Everything's going along pretty smoothly?
Yeah.
Now, I heard you have a test coming up.
Yeah, I do.
Should we get ready for it?
Sure.
All right. You know what? We're going to do a quick problem so we can help you get prepared for your test so that you ace this test. I'm
Okay.
sure you will anyway, but we'll help you out a little bit right now. So let's go ahead and work on this problem. So you're working on division in your regular classroom.
Yeah.
So head on over to the board and we'll write this up there. So we have 1,365 divided by 12. And what I'd like you to do is explain this to Cindy as you're doing it. And then when you get to the end, kind of explain, because there's going to be a little something going on at the end of this. All right?
So 12 can't go into 1, so we need to go 2 to 3. 13 divided by 12 is 1. 12 times 1 equals 12, and we subtract. 13 minus 12 is 1. We can't divide, so we need to bring down to 6. 12 can go into 16 one time, so 12 times 1 equals 12, and we subtract. 16 minus 12 equals 4. Now we bring down to 5. 45 divided by 12 equals 3. 12 times 3 equals 36.
I'm going to move this down a little for you, Brian, so that you can write a little better.
Okay.
There you
thank
go.
45 minus 36 equals 9. And we have a remainder of a 9. To check, we can multiply.
So instead of checking it, let's just jump to how to write that answer. Because right now you've got 113 remainder 9, but if they don't want a remainder, how would you represent the answer now?
We put the remainder into as a fraction.
All right, so go ahead and do that.
So since the divisor is 12, we put a 12 underneath. 9 12s is equal to 3/4.
So you're simplifying, yeah.
Yes, because we're dividing by 3. So now we have 113 with 9 12s. I mean 3/4.
Yeah, so you just write it down below if you want.
Yeah.
There you go. Nicely done.
Nice job.
All right.
Thank you.
Nice, easy one for you right there, and that helps get you ready for your test coming up, right?
Yeah.
Excellent. All right, 636-4357 is the phone number. We do have phone tutors available until 5:30, but right now it's time to check out today's Math in the News. All right, so today's Math in the News has to deal with this month of October. So, Brian, what month is October in the calendar year, the number of the month? Like we know January is the first month.
Yeah.
Do you know what October is offhand?
The 10th.
The 10th month, right? Do you think it's always been like that?
I don't think so.
Why not?
Because like in some calendars, they have one extra month.
Okay, well, not all calendars are the same, are they?
Yeah.
All right, well, you know what? October, do you know what octo means?
8.
8, right? Like an octagon is 8, octopus, the 8 arms and stuff like that, right?
Yeah.
So October used to be the 8th month. That's why it was named October. So if you look at a Roman calendar right here on the upper left, we can see this was the Roman calendar and there were 10 months, but October was the 8th month at that time, right? So that would make sense why it's called October, right? But then the Gregorian calendar came along and there are now 12 months, okay? So everything got moved and shifted. So now there are 12 months. So here we can see October 2020, the month that we're in right now. And here you are, October 7th, world famous star on Do the Math, Brian from Ronald Reagan, 5th grade, right? Now, have you ever figured out, do you think there's a way where you could figure out a day in any year? Like if I said, tell me the day of the week that October 7th was in the year 1648.
I think it's possible.
It is possible. As a matter of fact, it is. And you know what? Are you able to take care of that equation for me right there? It's a little blurry, but I was wondering if you could do that. Like down at the bottom, the Gregorian calendar, right? You able to, or do you want a little help with that?
Yeah, I think I need a little help with that.
You know what? We're going to skip right by that one. We're going to go to something even better. All right? If you were in a room, so here, Brian, what day is your birthday?
October 25th.
You got to be kidding me. Coming up?
Yeah.
All right. So October 25th, did you say, or 26th?
25th.
25th. All right. So October 25th. If you were in, let's say, your classroom, if you were able to be in your classroom, there's probably around 30 students in there, right?
Yeah.
Do you think any of them would have the same birthday as you?
I think there's like a 30% chance of
Oh,
having
you're
one.
very, very close on that right there. All right? Because if we look right here, if we look at the x-axis, the number of people, all right, we have all the way from 0 all the way up to 100 people. And the y-axis, the probability of a pair of birthdays occurring on the same day, hits at 50% if you have 23 people in the same room. So if you have 23 people in the same room, there is a 50% chance, 50-50, that somebody is going to have the same birthday as you. Pretty remarkable, isn't it?
Yeah.
And we can tell that it is exactly 23 people. Now, if it happens with 20 people, you may have gotten lucky like that, but it usually works out where you've got 23 people. So, in all likelihood, if you find out all of the birthdays of the students in your room, what's the probability that somebody is going to have another birthday on October 25th? Take a look at the percents over here. What's the probability of it?
0.5.
Right. And what percent would that be?
50%.
There you go, 50%. And that's why October is named October, because it was originally the 8th month of the year. And we can find out about birthdays and things like that. There's all sorts of calendar math that you can do. That is today's Math in the News. We do have phone tutors available until 6:30. Whoa, we're extending everybody by an hour today. Big day. I just saw the phone tutors like, hey, what's going on in there? Hey, you know what? Kids need help. We're here for you. But anyway, we do have an opportunity to head out and about and see what's cooking in the real world.
Today we are with Baker's Outpost, and we're with owner Laura Journey. How are you doing today?
I'm good, thank you.
Laura, can you kind of give us a little bit of background on yourself?
Yeah, so I've been baking for a little over a decade, pretty seriously. I started baking when I was quite young, with my grandmother in the kitchen. It turned into more of a passion-turned business a few years ago with the bakery. And yeah, so we've been here for about 3 years with Baker's Outpost.
And last year you kind of gave us some examples of the many different types of breads that you bake. Continuing on, I know that with all COVID-19, a lot of people are baking at home and trying to find yeast and flour and things like that. It's been really difficult, and actually just trying to find things that we can bake at home. Any advice or anything that you're seeing?
Yeah, I know it's been quite challenging. I think things have eased up a little bit now, but we can actually do quite a few extraordinary things in the kitchen with very few ingredients. So today we'll be looking at a cake recipe with just a few ingredients that you should be able to find around your house.
Now, you're talking about ingredients because you're a professional baker, and I know with professional bakers you deal with a lot of weight and volume, but a lot of home bakers, we don't. Me being one, we don't deal with the weighing things out and doing by volume. Can you kind of go into that a little bit?
Yeah, baking's more of a science, so it's not like adding a pinch of this, a pinch of that into a sauce, and it requires a lot of precision in weighing. So last year we spoke about weighing and using grams in a scale. There's also another way of using measurements, and that is cups and teaspoons, and a lot of baking uses fractions. So today we're going to focus on fractions.
I kind of want to go a little bit more into fractions because obviously with math and I know you have that cake recipe for us. Mm-hmm. So a lot of people are scared of fractions. A lot of students are, and other people are just like, I love fractions. But baking is a perfect example of fractions, and they are kind of fun. Can you kind of go a little bit more with that?
Yeah, and so the most common way that we use math in baking is with fractions. Fractions are a huge part of baking. All the measurements in the US deal with cups and teaspoons in fractions, so goes down from choosing the right measuring cup to comparing sizes and then later doubling and converting.
All that. Now you're from Canada, correct?
Yes.
Now in Canada, are you metric system or?
We are, and so we do a lot of things with ounces and grams and things like that. So we will touch upon that actually in the recipe. There's something with the butter we'll come across where I will show you how we can do it Canadian way, the American way, and how we use different measurements around the world.
Now, was that difficult for you as a little kid or coming here as an adult to convert between the two, or is that something that you had already learned in mathematics?
It does throw me off. For instance, when I go to the grocery store to order deli meat, for instance, I go to order it in grams. Here it's ordered in pounds, so that's one thing that I still have to stop and think about. But I've pretty much mastered the concept. We also were taught it in school in our math back home as well. So I've grasped it pretty well, and then being a baker and using it every day, it's just become second nature to me. But the fractions I know kids tend to get hung up on. So hopefully we can make it a little bit more fun and a little bit easier to understand.
Okay, so when we come back, Laura's going to be talking to us a little bit more about taking fractions into recipes and how really quite easy it is to work with fractions. But for right now, we're going to send it back to you, Mike, at the studio.
All right, thanks for that, Mary Lou, and also Laura. I know that we've worked with her last year, and anytime Laura is baking and they're talking about fractions, I am more than happy to sample any fraction of the food that they are baking because it is always delicious, and I'll tell you right now, We do have phone tutors here until 5:30 this afternoon. Hey, don't forget, you can also check us out online at dothemathonline.net. And in studio, we have Brian with us, a 5th grade student from Reagan Elementary. And I forgot to ask, have you been at Reagan for a long time?
Yeah, quite a while. I've been there for 7 years.
Oh, since TK.
Yeah.
So you've been there a long time. You're pretty used to Ronald Reagan then, huh?
Yeah.
All right. Well, you know what? We're going to see how used you are to this type of problem. So this is something not that your regular class is working on, correct?
No, but we did order of operations.
Good. And order of operations is very important. And I've got a beautiful problem for you to work on later on. But let's go ahead and work on this one first. So first of all, let's read this first. So we've got 5. And then it's like a set notation, but we're going to work on that like it's a bracket, double bracket. And then we've got 8, another set of brackets, 2 plus, and then inside parentheses, 6 minus 3, close the brackets, minus 4, close up the end of it all. There's a lot of stuff to do there.
Yeah.
All right? So it may look complicated to some students that aren't quite familiar with order of operations, or they know about the order of operations, but sometimes problems like this can look a little overwhelming. So if you would, please explain to Cindy how to go through this properly, and if you get stuck, Cindy's right there for you.
So we work from the inside to outside. Since the first set of the parentheses are in here, 6 minus 3 equals 3.
So you started with your inside parentheses, okay.
Yeah.
Don't forget to write your 2 in there. Yeah, there you go.
Okay, so now we have this. We're now going to complete the braces. 2 plus 3 equals 5. So
So do you know what symbol to put between your 8 and your 5?
yeah, since some equations they have like a gap between it, that also means multiplying.
Yeah, since your 8 was against your bracket.
So now we have, now we have 40 minus 4. And don't forget the 5 at the outside. 40
So you did your
minus,
multiplication. Can you just put a multiply between the 8 and 5 just so people are up at the, yeah, there. There we go.
so now we subtract 40 minus 4,
And you know what? Yeah, there you go. I was going to say, go ahead and do it on the right side.
which equals, actually, which equals 36. Now we have this extra 5 at the outside, so we multiply. And we get 180.
Okay, nice job.
All right, nicely done. All right, go ahead, erase the board. You are on your way. Doing 1's not enough. Here we go. So now 2 cubed, so we'll go ahead and write it up on the board. 2 cubed. There you go.
Good job.
Times 6.
Okay, so we have an exponent here. Basically, it means 2 times 2 times 2.
Right.
2 times 2 is 4, and 2 times 4 equals 8. So basically, it says 8 times 6. 8 times 6 equals 48, and this is our answer.
Okay, nice job. So the thing that people sometimes mess up on is that exponent, huh?
Yeah.
Yeah, so that's good that you knew that it meant not 2 times 3, but 2 times 2 times 2.
All right, nicely done. Erase the board. You've got order of operations down, and you're feeling pretty good about it, right?
Yeah.
All right. Cindy, you know the problem that we're going to be doing right now with 4 4s. So if you would do me a favor and put 4 4s up on the board the way we need them. All right. Brian, I would like you to select a number between 1 and 10.
Can it be a decimal?
No, it can, but let's make life easier on you.
Okay. 5.
5?
Yeah.
All right, so make it equal to 5. Now hold on there, brother. Okay? You have to use those 4 4s and no other numbers. You put operations between them, whatever you want, any grouping symbols you want, and you have to use 4 4s to equal 5. Go to it and explain to us what you're thinking.
I'm thinking about maybe dividing by 4 and then by adding. No, it won't work.
Okay, so let's try something else.
I'm gonna try multiplying. I'm gonna put a parentheses. Plus 4 divided by. And then I'm gonna put another set of parentheses. So 4 times 4 is 16. Plus 4 equals 20. Divided by 4 equals 5.
Nice job.
Yeah, perfect. There you go. All right, nicely done right there. Erase the board, young man. You're quite good at this. Another 4 4s, please. Why stop at 1? All right, let's see. How many people are in your immediate family that live in your house?
4.
Make it equal to 4.
Okay.
All right, young Mr. Brian, let's go.
Okay, I'm gonna multiply. And then divide and subtract. Oh, that's not going to work. So I am going to add.
Okay.
And then subtract. And so no, it's not going to work because it would equal 8.
All right, so you can also think of grouping or,
Wait.
maybe you need to group something. I don't know. But you're doing pretty good so far, so just keep trying.
Wait, I think I got something. And I will divide by 4. And then, no, it won't work.
See, now, Brian, this is a beautiful problem for you because you were able to get 5 pretty easily, right?
Yeah.
And I know that you understand order of operations, which is why this is a beautiful problem for you, because in order to better understand it, the amount of time that we struggle on things is beneficial to us, actually, right? Because when we struggle with things, then more synapses go off, and we actually are developing our brain more. So keep going and keep telling us what you're thinking about as you go.
Wait, are we allowed to put exponents?
There are no exponents unless you use a 4, but then you're going to have a big number. 4 to the 4th is a big number. And then you would eliminate one of your 4s, but we're going to leave it 4 4s just like that with no exponents.
Is he allowed to
Okay.
use 44? Not that it would necessarily help here, but I know sometimes.
I mean, there are ones where you could do that, but we would like all 4s to be separated.
Okay.
Do you know anything about square roots at all?
Oh, yeah, I do.
Easy now, come on.
That might be something.
All right,
you
well,
could
that's fine.
use.
That's the only hint you'll give the
Okay,
young man.
I'm done.
Wait. It might be. Oh, that's going to equal 5. So I was thinking about multiplying, then adding, then divided by 4, which equals 5. So it wouldn't work. Minus 0. And then you.
Aha, now you're on the right track.
So 4 minus 4 equals 0. Multiply by 4, which equals 0. And then we add with another 4 and we get 4.
There you
job.
go. Nicely
Nice job.
done. There you go. See, it took a little bit of extra time, but you were able to do it. Now, that was one way to find 4, using 4 fours. Do you know how many other ways there are to solve it?
Hundreds of possibilities.
Oh, yes, indeed. But you know what? We're not going to make you do it hundreds of times. As long as you got that one right there, you're fine. Hey, we do have phone tutors available until 5:30 this afternoon. Don't forget, check us out on social media. We've got Facebook, Instagram, Twitter, and YouTube. And Brian, for doing some great work this afternoon so far. You've got yourself a meal courtesy of our friends at Broken Yoke.
Thank you.
Oh, congratulations on that. There you go. Yappy little chicks over there. All right. Anyway, hey, you know what? We'll be back in a little bit. But right now, we're going to check back in with Mary Lou and see how they're cooking.
And we are back with owner Laura Journey from Baker's Outpost in her kitchen, getting ready to bake a cake using fractions.
Yes.
Oh,
So,
okay, go ahead.
sorry. So looking at fractions, if you don't know what fractions are parts of a whole. So today we're looking at a very simple cake recipe. You should be able to find all of these things pretty easily around your house. I know sometimes flour has been a little bit tricky, but I think we are back to normal here. So we're gonna take this recipe and we are going to double it. So you can see here we've got a bunch of fractions in our recipe. So we're gonna start off with the butter. So we've asking for 1/3 of a cup of butter. So to double it, we can add it or multiply it wherever you're at with your math. And here we've got 2/3. And another way to look at that is if we've got a chocolate bar, and you break it into thirds, and you eaten 2/3 of the whole chocolate bar.
And that, again, looking at that, we know we're adding our numerators, but our denominators, we have the same denominator, and that's what we want, and we keep it the same, hence the 2/3.
Yes. So here at our double cake recipe, we now have 2/3 of a cup.
Is it,
Of
do you
butter.
always write down your change in recipes? Do you keep a journal when you change up recipes?
I do. So I have numerous recipes where it's the basic dozen, and then I've multiplied it 6 times, 8 times to get the quantity that I need. So if I need 144 cookies, I, double it 12 times, multiply it 12 times to get the appropriate number.
Okay, after our butter.
Okay, so we are going to work on, we've got 1.5 cups of sugar. So we're getting a little bit bigger fractions here. So we've got 1.5 cups of sugar, and we're multiplying it by 2 or adding it twice. So here I would take that we've got 2 wholes. And then we're left with 2 halves. So how are we going to figure out half plus half? We know that if we've got a cake and we cut it in half, and I eat this half, and you eat that half, we've got a whole cake gone. So we know that 1/2 and 1/2 equals 1 whole. So we're going to come back to our 2 and add 1, which equals 3. So we know now that 1.5 plus 1.5 equals 3.
So we have 3
So
cups
we
of
have
sugar.
3 cups of sugar. It sounds like a lot.
That's a
doesn't
lot
it?
of sugar. is what
Sounds
I
like a
was
lot of
thinking.
sugar, doesn't it? And so now we move on to our eggs. And that's a pretty simple one. We've just got 1 egg. So if we have 1 and we need 2, we can add 1. And if you're multiplying the recipe, we know that 1 times 2 is also 2. So we're using 2 eggs in our recipe. And this gets a little trickier when you have the recipe and your recipe calls for 1 egg. What do you do with half an egg? That can be a little bit trickier, but we will not get into that today. But it is one of those things that it can eventually make things a little bit challenging when you're having things. So again, we've got 1 teaspoon of vanilla. We know that that is 2.
Because
We have doubled it or added 1 plus 1. And then here, moving on to 1 3/4 cups of flour. Again, we get into the bigger fractions and it can be a little bit scarier. So we have 1 3/4, and again, we're adding 1 3/4. So here you can see that we've got 2 wholes. So I'm going to write that here. And then we're going to add 3/4 plus 3/4. And so we see now here that we've got the common denominator. So what I'm going to do, I'm going to add the 3 plus 3. Which
over 6/4, yeah.
gives you 6/4.
Fourths. And right there, we're going to pause a minute because we're looking at that and we have an improper fraction, right? And so there's going to be more math that we're going to need to get into, but we're going to come back to that in just a second.
Perfect.
But for right now, we're going to head back to the studio.
All right, thanks for that, Mary Lou. A lot more to learn from the kitchen right there. All right, in studio we have Brian with us, a 5th grade student from Reagan Elementary, and he's been there for 7 years. One more and you're out of there, huh, buddy?
Yeah.
That's right. All right, you've been doing some great work. We kind of got you set for your test tomorrow where you're dividing by turning remainders into fractions and then even simplifying those fractions, so that's good. You've done some excellent work with order of operations and even took on the 4 4s, took that challenge on and did 2 of those numbers, as a matter of fact. So now it's time for something a little different. Are you ready for this?
Yeah.
All right, let's take a look at the problem together. So here we go. And you can write whatever on the board you want to, okay, to help you solve this problem. So a particular load exerts pressure of 26 pounds per square inch, okay? So imagine something pressing down on something and it's applying 26 pounds per square inch. Okay, so I don't know if you want to write that down or keep it in your head, but it's up to you. So 26 pounds per square inch. Now the question is, how many pounds per square foot is this? So if it's 26 pounds for a square inch, it's not going to be 26 pounds for a square foot, is it?
It's not.
All right, so think about what you want to do. You and Cindy talk it over and go ahead and work on it.
So there's like 12 square inches in 1 square foot, right?
So there's 12 inches in 1 foot.
foot.
So if you draw a square inch, what does it look like?
Is it about?
And then it would have like 1 inch by 1 inch, right? So if you draw a square foot, so just draw a bigger square. Okay. So if it's a square foot, that means it's 1 foot by 1 foot for the length and width. So how many inches would each side be?
12. Okay.
So if it's 12 by 12, how many square inches is that?
144.
Very good.
So since there's 12 square inches, we multiply 12 times 12.
Exactly.
Now we get a 4 here. Now we get a 2 here. Put the 0. And then we get a 2 and 1. And we add 4. 4. So we get 144. Now we need to multiply by 144 times 26.
Yeah, so the 144 is how much a square foot is, and then you're figuring out.
Yeah, so we multiply.
Yeah.
This should be actually really easy. 24, then down to 2. So 24 plus 2 equals 26. 6 times 1 is 6, plus 2 equals 8. Bring it down to 0. 2 times 4 is 8, and then 2 times, we do that again. I'm going to erase this.
There you go. I was going to say, erase some of that stuff on the side, make it easier for yourself.
And then 1 times 2 is 2. I'm going to erase the rest.
There we go. That's pretty good right there.
Okay. So we add 864 plus 2,880. 4 plus 0 is 4. 6 plus 8 equals 14. Put up the 1. 8 plus 8 is 16. Plus the 1 equals 17. 1 plus 2 equals 3. So the answer is 3,744.
There you go. 3,744 pounds per square foot would be the same as 26 pounds per square inch.
Yeah.
So there you go. So you've
Nice
done
job.
some excellent work right there. And young man, are you ready for another one? That would tell me you are ready. Erase the board, young man. Kind of the same thing here. So let's take a look at the new problem. A customer orders some brochures with 8.5 by 11 inch pages. So the size of a regular piece of paper is 8.5 by 11.
Yeah.
But they make brochures out of it. So they trifold it or whatever they do. Okay? The pages are printed on 17.5 by 22.5 inch sheets and then cut. How many of the larger sheets are needed if they want to make 8,000 brochures?
So they're printing it on a larger rectangle. You might want to write those dimensions down there.
17 and a half
by 22.5.
17.5 by
22.5.
okay.
And we need 8,000 of these smaller ones. So we need to know how many larger sheets we need to print these on.
So we're trying to get so we're trying to get these.
Yeah, so you need 8,000 of the regular size piece of paper, 8.5 by 11.
Yeah.
So basically they're going to print it on a bigger sheet. So you're kind of wanting to figure out, well, how many would go on that bigger sheet?
Okay. So they doubled it.
So go ahead and just like draw a rectangle to represent that smaller piece of paper. And then label it 8.5 by 11. Okay, so if you draw the bigger rectangle, like if you, let me see, here I'll draw it up here because it's harder. So if you drew a bigger one, whoops, ran out of room. Okay, so you'd have 17.5 by 22. So it'd be like this. So you're kind of trying to figure out how many of those 8.5 by 11s can you fit on that big piece of paper that they're going to print it on. So then you can figure out how many you need to print the 8,000. So what did you notice about the 8.5 compared to the 17.5?
They kind of doubled it basically.
I forgot the half on my 22 right here. There we go. So if they doubled it, how many do you think you could fit in there?
About 2.
Okay, so if I went like this and I split it, let's say I split it here.
Right.
What size would this be then?
That would be 11 and 3, about like 2.6. No, so it would be this would be almost the same size as this basically.
So what I did right when I split it right there, which number did I cut in half? Because I didn't cut both of them in half when I did that.
Yeah, so it should be 8.5 by 11 still.
So let me see, hold on, my pencil's not working. So if I cut this piece in half, right?
Yeah.
Because that's what I did, I drew a line here. Did I cut this piece in half?
No.
So that length is still 22.5, right?
Yeah.
So can I fit more on there?
Yes.
How many do you think?
I think 4.
So you think 4 total or 4 more?
4 total.
So because I can go like this, right?
Yeah.
So each one would be, so now that each number's cut in half, it's going to be close to this because this is a little bit more than double of 11, right?
About by a half.
Not quite, but enough to where you could make 4 on there, right?
Yes.
Okay, so now we need to know what is the final questions, how many of the bigger pieces you need to make the 8,000
Correct.
smaller pieces. Okay, so now we need to know how many pieces do we need?
Okay, so divide that by 4, which divided by 4. 4 can go into 8 2 times. Subtract. But 4 can't go into 0 any. So we can't like get into 0. So we put a 0.
Good.
And we just keep on doing that until we run out of zeros.
That's all right.
Hey, you don't need any, we know there's zeros, right?
Yeah.
Yeah. So about how many do we need of the big pieces of paper?
2,000.
Good.
Very good, so 2,000 pages. So that's kind of reasoning your way through it by drawing a little picture and then taking a look at the measurements. You could do that and you can see, yeah, I could fit 4 of these on that one instead of thinking, well, I could put 2, right? Because that's the way a lot of students look at it. They go, oh, I could do 2, and then they go, I need 4,000 pages. But you still can cut that in half again, all right? So I've got this is a tremendous problem for you coming up, all right? Erase the board because you're going to need it all. So do you have any idea how interest works?
No.
Okay. If you put $100 in the bank and you leave it there all year, you're going to get more money because you're going to gain interest with it being there. Okay? So let's say it's 3% interest and you have $100. At the end of the year, you're going to have $103, all right? Because you get the $3 in interest,
Yep.
all right? It's added to the total. Now, it's the same thing if you owe money. Let's say you owe me $100 and I go, every year I want you to pay me 30% interest. So at the end of the year, you still owe me $100, but is it only $100?
No, plus 30% interest.
So what's the total you're going to owe me?
So I'm gonna owe you $130.
$130. So you see how this works?
Yeah, I get
All
it
right,
now.
so here's the problem you're going to be working on, all right? We'll take a look at it together. If you borrow money for a car, and let's say you're going to borrow $1,000, all right? So you may want to put that in the corner somewhere. You're going to borrow $1,000, all right? And the interest rate is going to be 6%. So you can put 6% interest. And it's 6% interest every year. All right, so just like we were talking about, you get 6% interest every year. Okay? The question is, how long until your debt doubles if no payments are made? So how much money do you owe me right now at the beginning?
1,000.
$1,000. Now what is double that?
2,000.
$2,000. So you have to figure out how many years is it going to take until you owe me $2,000.
That should be 2 years, right?
2 years?
For until you get $2,000.
Well, it's going to be more than 2 years, because at the end of 1 year, how much will you owe me?
Oh, because you get interest.
There you go. All right. So, Cindy, maybe up on the top, you may want to make like a graph with years and money owed or something like that, some sort of a chart.
You
So-
want a graph or you want a
Well, not a graph, but a
just like
table of some
so
sort.
like year one
Right,
after the first year's passed?
right. So maybe, Brian, go ahead and take the borrow $1,000, erase that,
Here.
and write it over on the other side of the board.
Right above where you put interest, just put $1,000.
There you go. So you're going to keep going until you owe me $2,000. All
There,
right?
so I'm going to put 5 to start. Let's figure out how much you owe after 1 year has passed.
Okay, so we
So
need
basically, how much interest would happen that first year?
$60.
Okay. So how much would you owe then?
1,060.
Okay.
And then
All right.
that should become 1,120 next.
Wait, hold on. Because now our interest is based on, are we basing interest on the
You're going
original
to put
amount
the
or the new
6%
amount?
interest on top of the $1,060
So we're compounding interest.
Right.
Okay. So
Oh,
now,
oh, we're not yet.
now we're paying interest on this amount.
So how did you
Okay.
get $60, first of all?
If you have $100 in your bank account, 6% of it would be 6. But since you have $1,000 in your bank account, you would add an extra 0.
Good. So that's logically thinking about it. Now the numbers are going to get a little bit more complicated. So you may need some help, which is why I slid the calculator over for you in case you want to use it. Okay? So now you've got $1,060, but you owe 6% interest on top of that. So how do you figure out what the total is going to be now?
So it's not perfect hundreds now, right? So
Yeah.
we have to use some math. So do you know how you could get the 1,060 mathematically from 1,000 and 6%?
It would be 61 interest right now, I think.
Wait, say that again?
Would it be like $61 of interest?
So what you're going to do is when you have your amount, you're going to multiply it. Do you know your decimal of 6%?
No.
Here, I'm going to show you an easy way to do that.
Isn't it
right.
0.006?
If you got a 6% on a test, would that be good?
No.
Probably not, right? You'd be like, whoa, 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 what happened here, right? Well, watch. I'm going to show you on the calculator here, okay? 6% means 6 out of 100, doesn't it?
Yeah.
Okay, so if I go 6 divided by 100, I get 0.06. I know it's kind of hard to see in some, there we go. All right, 0.06. So that's 6%. All right, so now you're going to take 1,060 times 0.06. Does that make sense?
So 1,060.
And he's going to let you
Yeah,
use
use the
the calculator
calculator
so
here,
it
because
doesn't take
otherwise
quite
you're
as
going to
long.
fill that
Yeah.
board up quickly.
Yeah,
you're
so
gonna
our
take-
last amount, 1,060,
60
Uh-oh.
point.
and you're going to multiply it by 0.06.
So 1060 divided by 0.06.
Multiply.
Oh, multiply.
And what do you get?
So divided by 0.636.
So you're gonna do this 1060 multiply by 0.06.
Okay.
And what
Tell
do you
me
get
what
as
you
an
get.
answer?
63.6.
Well, hold on. Hold on a second. Let's try this again. All right, come on over here. All right, put it down there. Clear it out. So go 1060 times 0.06.
63.6.
Okay, so 63.6 turns into what?
63.6%.
But we're talking about money. So how much money is that really?
$63.06.
And how much?
And 60 cents.
60 cents. There you go. Because a lot of students say 6 cents, but you need that zero after. So now we're going to take this 1060 and add 6360 to it.
Right, because this is our extra we're paying, but it's gonna add to what we already had here.
So you're going to
So you're gonna do 1060 and you're gonna add $63.60 to it.
1,060 plus 63.60%. So you have 1,123 and 60%. I mean 60 cents.
60 cents.
There you go. So you have 1123.60 at the end of year 2. Now watch this. This is going to be a little shortcut I show you. All right.
Okay.
We know that we owe 1,060, right?
Yeah.
And we're going to times it by 6%, but we owe 100% of the previous amount. So we're going to times it by 1.06 because that means 106%.
Okay. Yeah.
Does that make sense?
Yeah, it does.
Then we hit equals and look at what we get, 1123.60. So we skip a step.
Right.
So now, if that makes sense to you, I'm going to have you keep working on this, all right? And we're going to come back in a little bit and see how many years it takes Brian to double his debt to $2,000. But we do have this opportunity. One last time, we're going to go out and visit with Mary Lou and Laura.
We are back at Baker's Outpost with Laura Journey, owner, and we are in the middle of doubling a cake recipe. And we kind of left off with measuring the flour because the flour is not that quite easy as like a half or a whole. We have the 1 3/4. And we kind of left it as in proper fractions, so let's continue on.
Right. So we need to simplify it here. So we know that we've got 6 over 4, and to get that simplified, 4 goes into 6 one time, and then we are left with 2/4, which breaks down to 1/2. So here we know that 3/4 plus 3/4 equals 1.5. So coming back to our whole number here that we have the 2 cups of flour, we're gonna add 1.5 cups of flour. 2 plus 1.5 equals 3.5. So here we've got a total of 3.5 cups of flour.
And a lot of times when students are breaking that down, they forget to add those whole numbers back. And I like how you brought that back to it.
Yeah.
Because a lot of times they forget to do that.
Yeah, with my daughter's math, it's one of the things I've been focusing on is to come back and don't forget that number that you've got to add. And so we've got our flour calculated here. Now we're moving on to something, it's a little bit trickier for some. We're working in teaspoons. So it's asking for 2.5 teaspoons of baking powder. So we've got our 2.5 and either multiplying or adding it. We can see that our whole numbers here, 2 and 2, are 4. And then we're left with our 2 fractions, 1/2 plus 1/2, which we know equals 1 whole. So again, if you remember your cake picture and I eat 1/2 and you eat 1/2, the whole cake's gone. So we've got a whole here that we're gonna add. 4 plus 1 equals 5. So we've got 5 teaspoons of baking powder. The interesting thing, and to make it a little more simple, instead of measuring out 5 teaspoons of the baking powder, in Baker's math here and conversions, I've got a little chart here. We know that if you come here, 1 tablespoon equals 3 teaspoons. So if we take 3 of these teaspoons to make 1 tablespoon, 1 and a capital T there is usually for a tablespoon, you're left 5, and you've taken 3 of those teaspoons away, you're left with 2. So you're going to add 2 teaspoons, which are your remaining teaspoons. So here we've got 1 tablespoon plus 2 teaspoons.
So real quick, Laura, you have these in front of you.
Yes.
Let's kind of show them what a tablespoon and a teaspoon, because a lot of times people kind of get confused.
Absolutely.
Which tool would you use for a tablespoon? Which would you use for a teaspoon?
So here, the biggest one typically on your measuring for your spoons is a tablespoon. And then your other most common used is a teaspoon. So when we know that we need 5 teaspoons, we can visualize 3 of them going into here and then 2 into here.
So we would use only 1 of the large.
Correct.
And then we would do 2.
So let's show that we can do 1, 2, 3, 4, 5. So that's 5 teaspoons.
Or we can do.
Or we can do 1 tablespoon. So we know that's equivalent to 3 teaspoons. And we've got 2 remaining teaspoons left.
Well, Laura, this has been wonderful. Thank you so much for allowing us to come into your home today.
Thank you so much for having me.
And showing us how easy fractions really can be, especially in baking.
And it's a lot funner when you get a cake out of the deal.
Now, if people need to contact you, where can they reach you
Yeah,
at?
just feel free to reach me with any baking questions, any math questions at laura@bakersoutpost.com.
Again, thank you so much. And that's it today for Baker's Outpost and with Laura Journey.
1-9?
And Mike, we're
Yeah.
sending it back to
I got
you
one.
in the studio.
I got
All right,
180.
thanks for that, Mary Lou, and thank you also to Laura
1,000.
once again for helping us out. We've got Brian working on his
1,898.
problem, trying to see how long it's going to take until he owes me $2,000, and he's on year 11 right now. And what are you getting for that?
Okay, what's year 11 again? 1,000?
I'm multiplying 1,790.85 times 1.06, and I got 18,098 and 30 cents.
So 1,000.
There you go. So you're getting close.
898.
Anyway, so hold on there, Brian. Come on back
30.
over here for a minute, because I know you're going to solve that quickly. One question for you. Did you have fun today?
Yes.
Good. And I think you learned a little something also. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.